My name is Kellen Montgomery. I'm a first-year PhD student in geospatial analytics at NC State. And I'm going to share with you today some of the first research I've been doing as part of this program. I'm using unmanned aerial systems to see how we can leverage the 3D crop models or the canopy models that you can get from UAS for understanding yield and other variability within a field. So by 2050, we're expected to have 10 billion people on this world. So that will come with a lot of challenges. We have to understand how we can produce enough food to feed everyone, but then also how we can make sure our food system is reliable, resilient, sustainable. And one of the strategies for doing that will be agricultural intensification. What I mean by that is just increasing the amount of food we produce on the land we already have in production versus converting more land into agriculture. Already we see a lot of agricultural land being converted into other land uses like residential or other urban development. But also agriculture can have pretty big cost to ecosystems, so it's not really feasible for us to convert more land into production. But this kind of intensification will come with a lot of challenges. One is just competition for natural resources, water in particular. We see a lot of examples of this already where ag is in direct competition for water with urban use and other industry use. Also, degradation of soil and water, loss of biodiversity by removing other land covers, uncertainty and changing climate conditions. And also related to the above bullet points is just an emergence of new pests and pathogens, in particular with increasing global trade, these changing climate conditions, pests and pathogens will be a real challenge in the future. So this simultaneous need to increase production but also conserve natural lands is kind of a dual challenge that we'll have to face simultaneously going forward. Precision agriculture is one of the major strategies that we'll be using for addressing this challenge. In its simplest term, precision agriculture is using tools and data analytics to identify variability within a field in order for a farm manager to apply precise management to those areas and increase yield. Geospatial analysis is a really key component of this. And remote sensing is one of the most common tools. You can use satellite remote sensing with multispectral data to compute vegetation indices. But remote sensing with satellite is limited by spatial resolution and temporal resolution. So unmanned aerial systems is really emerging as a valuable tool for precision ag. Not only can you get really high centimeter resolution if you need it, but also the temporal resolution. You can deploy a drone in well-timed with whatever you're interested in looking at in your field and then continue to monitor it over a season. So another cool thing about UAS is that since it's taking imagery, you can apply this photogrammetric technique called structure from motion to reconstruct a 3D model of whatever's on the ground. So just to briefly describe this, the top image there is actually a 3D model of a Raspberry Pi. And in the bottom is some images of different angles of that Raspberry Pi. So the structure from motion algorithm basically identifies a point on an image and then identifies that same point on all other images and then connects those via tie points. And then does the same for as many images or as many points as it can find and then connects all those points. So since the images are georeferenced, the algorithm can actually tie all those together to get a XYZ coordinate for each of those points and then reconstruct a 3D model. So you can get something like this, a 3D model of sorghum in this case. So when I'm thinking about how to leverage these 3D models, one thing that comes to mind is just looking at the uniformity of a canopy. So you can see on the left, we have a really nice uniform field of grain sorghum. This is the kind of field a farmer would be proud of. He would know that it was going to have high yield, versus the picture on the right, which is actually from my study site, that is really, really variable. You'll get just uncertainty in how and what your yields are going to be from a crop canopy like this. So I wanted to take a look at a couple of questions. One is, what kind of information can we get from 3D models about crops? And then can we relate the structure of the 3D canopy models to crop status? So I'm talking about yield in this case, but it could also be nutrient deficiencies or pests or pathogen severity. And then a really important thing that has come up as I've been doing this research is, what are the best parameters to use when you're reconstructing these 3D models from structure from motion, and then also when you're interpolating the point cloud to a surface model. So I'll talk about that in a little more. So for this study, I monitored a site at a research farm in South Raleigh, part of NC State. It's a half-acre field broken into 52 plots. With grain sorghum planted. It was actually a fungicide trial where they were looking at the effectiveness of fungicide on Fusarium head blight. So it was a good opportunity for me to monitor a field where they were also collecting a lot of field data that I could use. I have yield per plot, but also disease severity per plot, and then the fungicide treatments that were being applied. So I used a DJI Phantom 3 Pro, which is a regular RGB camera, no multispectral data, and did 3 flights in September and October of last year. I flew at 30-meter altitude, which is pretty low, but I wasn't sure how much detail I would need for this study, so that's where I started. 80% image overlap, and then a slightly oblique camera angle. There's been research that shows that if you use oblique camera angles, you can actually, for one, mitigate some of the error that you get just from imperfections in the lens of your camera, but then also reconstruct 3D surfaces in more detail. I use 7 ground control points to georeference the images. So just overall picture of how I did this. I basically processed the UAS images using Agisoft PhotoScan into a point cloud, and then interpolated that point cloud into a digital surface model using GrassGIS. But I also had to get bare earth, so I used LiDAR data to interpolate a bare earth surface, and then detrended my digital surface model for topography using that DEM. So as you can see in this image, by subtracting the bare earth elevation, you can get a representation of actual crop heights. I also had to correct for some systematic error shifts, mostly related to inaccuracy in the GPS data I collected in the Z direction, the elevation values, and also had to remove outliers. So these last 2 steps were really important part of this process. Just to illustrate that a little further, this is one of my digital surface models before I did any error correction. The red surface is 0 elevations, representing ground. So you can see my whole elevation is shifted downward, and we have a lot of outliers in the bottom. So I used just raster sampling and then interpolation to create an error surface that I then subtracted from my digital surface model, and then just simple map algebra to remove those outliers. And you can see the red areas in the final model are still slightly below ground, but those were within 5 to 10 centimeters, so I accepted that as acceptable for this study. And so in order to quantify the structure of the canopy, I was looking at these different characteristics. So one is height. I wanted to have an idea of what areas were low versus high, the roughness of the canopy, and then also how uniform it was. And also I was interested in looking how growth over time might affect yield. So for height, I just looked at the central tendency of height, the mean. And then for surface roughness, I used two metrics that are commonly used in geomorphology, canopy, elevation relief ratio, but in this case it's canopy relief ratio, and then just standard deviation of heights. To tease out the uniformity, I used variograms. The idea there was to look at the distance that heights were spatially or spatially correlated. So my idea there was that a more uniform canopy would have more spatial dependency in heights across the plot. And I also used just simple histogram analysis as well. So for growth over time, I did a pixel by pixel linear regression over the time series, and then weighted the slope of that linear regression by the coefficient of determination. And then I applied some statistics to see what was significant. Basically, I just extracted the canopy heights by plot, computed the metrics for each of the plots, and then applied a multiple regression model with yield as the dependent variable. But I also had to test for spatial autocorrelation and then apply a spatial regression variant in the cases where spatial autocorrelation was still present. Okay, so some of my results. So for the structure from motion processing, depth filtering was the most important parameter that I looked at. In Agisoft, you can use no depth filtering, mild, moderate, or aggressive. So I thought for such a complex surface that actually it might be more important to keep as many of those points, because those deeper points or lower points might actually have meaning and value when you're looking for gaps in a canopy, for example. So I have some comparison here. In the ortho photo, I've highlighted an area that has a gap, and then we can compare across all of these different parameter settings how the algorithm captured those gaps. So you can see actually disabling the depth filtering did a much better job of capturing the gap in the canopy in this case. And then just another example of the same parameters, but just in a 3D view. So here is a peak that I've circled that I believe represents a sorghum seed head, so the very top of the plant, which is really important for when you're looking at yield. That's actually the part that's harvested, is that seed head, compared to that same point in mild versus moderate. So you can see that peak is kind of smoothed out in those other parameter settings. So based on this kind of visual analysis, I decided to use no depth filtering. And for interpolation, I varied tension and smoothing. So these two parameters basically dictate how strict your surface is as far as passing directly through your points. So in a lot of cases, you might want to smooth out some of that noise and allow your surface to deviate from your point cloud more. But in this case, again, I thought it might be more important to actually show all of the ruggedness of the canopy. So the first example, high tension, no smoothing, these points, this surface is passing almost directly through the points, versus on the right where we have a more smoothed model. Overall, the surfaces were actually pretty similar. I mean, there's a lot more noise in the zero smoothing surface. However, I did find some examples where some of the peaks were smoothed out. So I'm still kind of exploring what the best parameters are to use here, but for this study, I used zero smoothing. Okay, so here's a map of the yield across the field. So as you can see, there's there's a pretty strong spatial pattern. In the southernmost plot on the bottom, we had the highest yields by far. And this is a plot of the mean crop heights. I actually subdivided the plots to represent what I thought was about the size of a plant, so we could see the interplot variability in heights a little bit more clearly. And actually, some of the tallest plants were in the northernmost side of the plot, but those yellow values, a lot of them are surrounded by very, very low heights as well. So there's a lot of variability, poor stand development in those plots, versus on the southern side of the field, we had pretty high crop heights overall, but then also just more consistency. So this represents rugosity or standard deviation, surface roughness. There wasn't as strong of a pattern here, but you can definitely see the areas where there was poor stand development, especially in that top row. All of the plots are kind of, the edges have high standard deviation because there's quite a lot of canopy gaps. And this one is pretty important because this is a representation of the time series. So this is which raster in my time series was the highest point. So with 0 being the first survey I did, 2 being the second, and then 1 being the second, and then 2 being the third. So you can see in this map, almost all of the sorghum plot areas were actually highest at either the first survey or the second survey. This makes sense, though. With sorghum, they actually leave it in the field for about a month at the end of the season to let it senesce and dry out. So because of the timing of the surveys, it makes sense that the canopy was actually kind of shrinking over this time series. So this kind of emphasizes how important the timing of your monitoring is. So for the statistics, there was quite a bit of spatial autocorrelation that was not accounted for in the variables I used. But I've done a little research into this, and they're all driven by topography. So there was kind of a slight slope in the field. And when I look at overland water flow, so how much water is accumulating in the field, those southern plots with the higher yield had much higher water flow accumulation. So that, in combination with solar radiation being a southern-facing slope, could account for the spatial autocorrelation. But I used a spatial variant of a regression model to just account for that autocorrelation. And here are the metrics that were most important. Mean height was very significant. The treatment that was applied was significant, but then also kurtosis of the histograms. Kurtosis is just the amount of spread that a histogram has. So for example, I have a histogram of the lowest yield plot versus highest yield. And you can see that the lowest yield plot is a lot more spread. And this actually ended up picking up on that issue of uniformity the best. As you can imagine, if there are a lot of gaps in your canopy, you would have a lot of pixel values with very low height. And so that would show up in your histogram versus the high yield plots had more consistently taller plants. So some things I've been thinking about with this research is that depending on their crop type, this might be more or less effective just simply because of the limitations of structure from motion. Sorghum is a grass species. It's very complex canopy. So I'm still kind of looking at how accurate the SFM reconstruction is. And I think one important thing for investigating that will be using open source software. Right now, I really don't know how the depth filtering algorithm works along with the other parameters because it's proprietary software that I'm using. So I'm hoping to be able to switch to some other open source option. Also, the timing on surveys is really important. I'm planning to repeat this when I can monitor from the very beginning of the season and see how the crop develops and how that relates to yield. In this particular field, there was pretty poor stand development because of a competition from weeds and also variability and some of those topographic factors I mentioned. Another thing is very precise georeferencing is really important, especially when you're looking at a time series. You want to be able to compare your time series with a confidence that your elevation values are consistent. And then I'm still interested in exploring the uniformity metrics a little further. I think kurtosis was the most valuable in this case, but Also, I would like to look at bimodal histograms. So I noticed that in some of my histograms, there was two peaks, one at the kind of normal crop height, but then also a peak where there was like grass. So I think being able to identify histograms with two modes might also highlight issues within a field. So just some conclusions. Parameters that you use when you do structure for motion are really important. And also interpolation, especially when you're trying to reconstruct really complex and small features. I saw that crop height and uniformity are very important predictors for yield. However, canopy roughness was not important. And then topography-driven parameters should be included when you do this kind of analysis to account for that spatial autocorrelation. And so some of the just take-home messages are that we can combine this 3D information with the spectral metrics or indices that we traditionally use to improve the accuracy of remote crop assessments. And also that UAS and geospatial analytics are going to be critical tools for solving this production conservation challenge going into the future. That's it. Thank you. Yeah.
So you said that calibrating the model for elevation, you had to adjust because of once it collected the GPS. What kind of GPS was used? I guess it's what we use for those.
Yeah. So why was it so bad? It was a Trimble. I can't remember the exact model, but it has the potential to be very accurate. I think it was probably more related to user error, honestly. But what's really exciting is that some of the RTK drones are becoming less in price. So there's one that's $8,000, which is a huge price decrease that's recently come out. So I think that will probably be the best way to handle this going forward is using RTK. Yes?
Perhaps leading to a lot of the area defining, a lot of variance in the data thereafter. But if you're planning to use a for RTK for the next round, and establish better ground control.
Yeah.
I think your methodology is awesome. I think it's really interesting, but I think you start off with bad data.
Yeah.
To be able to, what you do with the bad data and tease out was very interesting.
Yeah. Oh, yeah, I'm very, very aware of that for sure. Yeah, I'm looking forward to this growing season to try it again. But I'll be using a Phantom 4 Pro this time, so maybe a little higher quality images. Still waiting for that RTK drone, but certainly the ground control will be better.
I don't think you have to do ground control. You won't need the RTK.
Yeah.
What you're doing with that.
Yeah.
But I'm glad to hear that you're getting the equipment you need to do a good job.
Yeah. 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 Thank you. Yeah.
Do you think the resolution plays a role in whenever you're georeferencing and you're running through the Raspberry Pi? Do you think the resolution could give you like a better chance of establishing differences than it would like, you know what I'm saying?
Good. Better for to get better ground sampling distance.
Yeah. What I'm saying is there a correlation between the quality of the data and the pixels used? Do you think could that give you a better variance in the structures you're actually capturing from that oblique angle? Like, because right now, I don't know if the pixels are a little bit, it's not as good a resolution.
Right. Yeah, I actually used the basically the minimum resolution I could get with the ground sampling distance that I had. So, I felt that was probably the minimum I could do, but it was also probably less than I needed, honestly. But because I flew very low, I felt comfortable using that small of a resolution. But it's definitely a question I'm still looking at, is what resolution is really needed for this kind of analysis. 1 centimeter. I don't know if I mentioned that. 1 centimeter is what I use. And so that's really, really, really high. So still kind of a research question for me. In the back.
You had mentioned open source.
Mm-hmm.
Are there those exist?
Yeah, definitely. OpenDroneMap. Yeah, I've used it once, and they have like cloud-based processing, and it's going to be integrated with GrassGIS as well. So that's what I'm looking at now.
That runs on Linux as of now, right?
You can run it on Windows too. Mm-hmm. Yeah.
And they've made some pretty good progress in the ability to generate the full cloud in the past couple of months.
Great. Yeah, I think that's the having the interface to like place your ground control and really understand how the model is working. That's something I'm looking forward to with OpenDroneMap. Yes.
Just out of curiosity, it's not a GIS question, it's probably a stupid question, so I apologize in advance. But you said that the particular planning there was a fungicidal study.
Mm-hmm.
Was the application of that uniform across the site, or was there some variability in that? And was that a factor?
Yeah. Yeah, it definitely was. Every plot had a different treatment. They applied different types of fungicides, and then also they timed the fungicide treatment differently. And I did include that in the regression models, and it was a significant factor in yield. Yeah. Mm-hmm. Yeah, so I guess it's important to know what's going on the ground, so you can include that in your analysis.
They have the same irrigation across all plots, like on the same node. Like, do they have like regular scheduling that you're aware of? Or?
No, it was just rain irrigation.
Okay.
And this plot was in the ground during two hurricanes, Florence and whatever was right before that. I can't remember. Isabel, is that right? Yeah, so that was certainly a big factor, is how much rain the plot received. And I think they're repeating this trial, as a matter of fact, for that reason. And they're going to control for weeds this time. They didn't do that. So, in the back.
So you mentioned a repeat, so the field is being repeated, just a mild suggestion.
Yeah.
You can just set control points in there,
Mm-hmm.
have a survey set control point in there, that you can see, and at 1 centimeter resolution, sure you can see it.
Yeah.
And so you would have survey control at a high accuracy.
Mm-hmm.
So you can repeat the study using the same control points over and over.
Yeah.
That might help you, especially on that seed value.
You mean like permanent control points? Okay.
The survey monument.
Mm-hmm. Yeah. We have one site that we monitor, not specifically for crops. Actually, it's more like soil erosion is what we've been looking at, that has some, I guess, USGS monuments. So it's great working with that data. I'm feeling confident. Okay. Yeah. Thank you. Any other questions? Well, thank you. It's really great suggestions you guys had too.